All right, let's dive into one of the biggest ideas in all of science: energy. I mean, it's everywhere. It powers our cars, it powers our bodies, it powers the entire universe. But the story of how we even figured out what it is, well, that's a wild ride, taking us from ancient philosophy to the very laws that govern reality itself. Let's get into it. It sounds like a pretty simple question, doesn't it? But the answer has changed so much over thousands of years. You see, energy isn't just some number you plug into a physics equation. It's an idea that had to be discovered, fought over, and finally proven. So let's start peeling back the layers. And our journey doesn't start in some high-tech lab. Nope. It starts in ancient Greece with Aristotle. He used this word energia, which basically translates to being at work or activity. For him, it wasn't about measuring things. It was a philosophical concept. It was the difference between a pile of bricks and a finished house that's actually being a house. It was about potential becoming reality. So this philosophical seed of an idea, that's where it all began. It was a beautiful, really abstract concept, but it wasn't science. Not yet, anyway. Okay, now let's fast forward, and I mean way forward. For more than 2,000 years, energia was just this idea philosophers talked about. It wasn't until the early 1800s that a guy named Thomas Young first used the word energy in the way we think about it today. Just think about that massive gap. It just goes to show you how incredibly hard it was to turn this abstract thought into something you could actually measure. So what was the key? What was the thing that finally unlocked this scientific mystery? Well, it was a phenomenon everyone experienced, but nobody really understood: heat. For the longest time, heat just seemed, well, kind of magical. For a long time, the best guess was a theory called caloric. The idea was that heat was this invisible, weightless fluid that would flow from hot things to cold things. And, it kind of makes sense. But a new, pretty radical idea started bubbling up. What if heat wasn't a fluid at all? What if heat was just the energy of tiny atoms in motion? And that old caloric theory really started to fall apart when people started looking closer. You had Count Rumford who, while he was boring cannons, noticed that the drilling produced a seemingly endless amount of heat. I mean, where was all this caloric fluid supposed to be coming from? And then Humphrey Davy did this really dramatic experiment where he melted 2 blocks of ice in a vacuum just by rubbing them together. He proved motion itself could create heat. The writing was on the wall. These observations were really the first dominoes to fall. The stage was now set for science to finally pin down, to measure, and to write the rulebook for energy. The big turning point came in the 1840s with James Prescott Joule. He built this brilliant little device where a falling weight turned a paddle wheel inside a container of water, and he proved with incredible precision that a certain amount of mechanical work, the falling weight, always produced the exact same amount of heat in the water. That was it. The caloric theory was officially dead. Heat was energy. And this amazing discovery opened the door for 2 of the most powerful and fundamental laws in all of physics. The first law is just so beautiful and simple. Energy cannot be created or destroyed. That's it. It can only change from one form to another. The mechanical energy from Joule's falling weight became the heat energy in the water. The total amount of energy in the universe, it's always the same. Now, the second law, that one introduces a new player to the game: entropy. And entropy is basically a measure of disorder or messiness. It says that in the grand scheme of things, the total disorder of the universe is always going up. Think about it. A hot cup of coffee always cools down, spreading its energy into the room. It never just spontaneously sucks heat out of the air to get hotter. It seems like nature has a one-way street and it's heading towards disorder. So these new laws gave physicists an incredible way to understand the world. But what about the next great frontier? What about chemistry? Could these universal laws of energy actually explain and maybe even predict all the chemical reactions that create, well, everything? This was the million-dollar question. I mean, could you just look at a couple of chemicals, do some math based on the laws of energy, and predict if they would react and what they would turn into? Could you finally replace all that tedious trial-and-error chemistry with pure predictive math? The person who figured that out was a quiet, kind of unassuming American physicist named Josiah Willard Gibbs. He was working pretty much by himself at Yale, but he would single-handedly build the mathematical foundation for all of modern chemistry. And his secret weapon was something he invented called Gibbs free energy. It was Absolutely brilliant. He found a way to combine the first law, all the heat changes, and the second law, all the changes in disorder, into a single, super powerful equation. This gave chemists a tool that could finally tell them if a reaction would just happen on its own. It was like getting a crystal ball for chemistry. He laid it all out in this paper in 1876, and it was so dense, so brilliant, that a lot of scientists at the time couldn't even really understand it. But once they did, it changed chemistry forever. No more guesswork. Now chemistry had what one of our sources calls the majestic logic of energy. And from these abstract mathematical ideas came the very technologies that have completely reshaped our world. Seriously, these principles are the unseen engine of modern life. They're fundamental to designing everything from the computer chip in your phone to the engine in your car. They're behind the development of new medicines and the engineering of rocket nozzles. This abstract science is literally everywhere you look. And this kind of brings us full circle. Energy isn't just a number we measure, it's really a universal language. It's the common thread that ties together physics, chemistry, biology, and engineering. It's the language that explains how pretty much everything works. So let's just recap this incredible trip. We started with Aristotle's philosophical idea of being at work. Thousands of years later, Joule proves that heat is just a form of motion. Then Gibbs gives us the math to predict chemistry, and finally, Einstein comes along and shows us that even mass itself is just an incredibly concentrated form of energy. What a story, right? Which really leaves us with one final thought. We've gone from thinking heat was some kind of magic fluid to understanding the laws that govern the cosmos. So, if energy really is the language of the universe, the question for us is, what are we going to learn to say next? What secrets are still out there, waiting to be unlocked? Thanks for joining me.